Do you know how to read the graphs that we sent with the antennas? Let's learn some important concepts to make this reading. You may have heard about VSWR and port-to-port isolation. VSWR is a measure that informs how much energy the antenna is reflecting. The antenna receives radio power and its function is radiate this to another antenna, but sometimes some of this energy goes back to the radio. This is called VSWR. We have to assure that the minimum of this energy reaches back the radio. If the antenna has a high VSWR, the following problems can appear: gain loss and noise generation. If a large amount of power returns to the radio, the antenna gains decreases and the power that should be received on the other side of the link also drops. The noise generation occurs because the power that returns to the radio is seen as a noise by itself. On each produced antenna, ALGCOM sends VSWR measurement and port-to-port isolation graphs. Let's see how to look these graphs. As an example, we are using the 5.8 GHz parabolic shielded antenna graphic. In the graph's bottom part, we can see that the analyzed range is from 5.25 to 5.875 GHz. In this area, you can see the VSWR data for each port, and you can check the same information on the sticker located on the back of the antenna. According to Anatel, the Brazilian National Telecommunications Agency, on the ATO 932, return loss values are required to be better than 10 decibels. This is the same as a VSWR smaller than 2. In our datasheet, we declare VSWR is smaller than 1.5. In this example, the VSWR levels are below 1.5, which guarantees excellent quality and a low return loss. And how about the port-to-port isolation? This is the measure of how much a port or a polarization is isolated from another on the antenna. We can analyze in this part of the graph the isolation measurements between ports of an antenna. If the isolation is low, the power that reaches at one antenna port is sent partly to the other port. We seek to ensure that these values are equal to or greater than 30 decibels, and we can check in the datasheet the same information. In the red line of the graph, we observe the limit set by ALGCOM, and we can note that the values are excellent. You may be wondering, why are the graph values negative? Our vector network analyzer measures transmission, so the values shown are negative. A minus 30 decibels transmission means 30 decibels insulation. Now that you know how to interpret the graph, make sure your antenna is of good quality and has all those important information stated in the datasheet. If you are looking for quality and trust, count on us.